Hello guys, welcome to your third lesson in your CCNA 200-301. In this lesson, we're going to look at how computers see IPv4 addresses. Now, in this particular session, what we're going to discuss is our previous lesson. We do a little recap of the previous lesson, and we'll also have a look at what binary numbers are, and then we'll see how decimals, which are the numbers that we have for IPv4 addresses, can be translated into binary numbers that can be seen by your computers. We'll also look at how binary is also translated into decimal. Let's get started. Now, in our previous session, we discussed what IP addresses are, and then we also discussed what subnets are and how to identify a particular IP address group. We also went further to see how subnet masks are assigned to individual or respective IP addresses from different classes. So we said IP addresses are made up of two parts, so which was the network part and the host part. We also saw what subnet masks were. We said subnet masks help us to see which part of the IP address belongs to the network part. And for that reason, we can do a reversal and see which one will belong into the host part. We also said that IP addresses can help us see how big a network is. And we said that will be discussed in subsequent videos. Now, we mentioned that what we're going to look at will be the first three classes, so class A right up to class C. And we said class A addresses have a subnet mask of 255.0.0.0. We also mentioned that class B addresses have a subnet mask of 255.255.0.0. And then we said, again, class C addresses follow the same format, but this time around have three of the 255s, so 255.255.255.0. Now, if you could look clearly at the various examples or the various classes and their respective subnet masks, we can see that there's a pattern which is building up. So for class A, we had only one 255, class B, we had two of the 255s, and class C, we had three of the 255s. So these are the various types and various types of subnet masks we have for various classes. And yeah, that's what we're going to follow on from. Now, in this session, what we're going to discuss is how computers see IP addresses. Yeah, so going to discuss how computers see IP addresses. Now, what do we mean by how computers see IP addresses? So IP addresses in normal sense, we have any number from 0 to 255. But then if you pick a classical example of an IP address, you have four numbers. So a number, another number, a third number, and a final number, ranging from any of them. So it can be 200, 240, maybe 13. So 4.200 or 240. So if I bring it down, we have 4, 200, 240, and 13. Now, this is what we know as IP addresses, but in the sense of a computer, the computer will not be able to understand what we mean by this. So the best way to do this is by translating it into what we call binary. That's how the IP addresses are sent by your computers. You wouldn't have to do that binary, that's converting the various IP addresses into binary, but then this is how the computers will be seeing them. So in our next slide, we're going to look at how binary is done. That's converting a normal number into binary, and then also look at how binary is also converted into decimal. So we're going to do a reversal. We do the first one, which is decimal to binary, then the subsequent one, which will be binary to decimal. Okay, so in this one, let us look at what a decimal number is. So a decimal number is any number it could be from, let's assume 0 to 10. So standard numbers, 2, 3, 4, 5, 6, in that order to 10. So 6, then we move to 7, we move to 8, we move to 9. So let me just put dash here just to say that up to 10. So 7, 8, 9, 10. All right. So every number, just to make it a bit clearer, every number, so 7, sorry, 1 second. So every number, so 7, 8, 9, 10, yeah. Every number like what we have here, can be translated into binary. Okay, what do we mean by binary? I'm very certain that at least everyone knows what this is. 2 power 1. 2 power 1 just means we have 2, but how many times do we have 2? Just one, so only 1, 2. 2 power 2 means we have 2 and we have another 2. So this will give us 4. 2 power 3, which means 2 3 times, which will give us 8. Now, there's always a confusion when people see 2 power 3, they feel it's 2 times 3. No, 2 power 3 means repeating 2 3 times. That will give us 8. Now we have 2 power 4. 2 by 2 by 2 by 2. That will give us 16. Then the next one, which is 2 power 5, with 2 by 2 by 2. That will give us 32. We have 2 power 6, which is 2, 3, 4, 5, 6. That's 64. And the last one, which is 2 power 7, which is 128. So 2, 3, 4, 5, 6, 7. That's 128. Now, we have 7 numbers here. So 1, 2, 3, 4, 5, 6, 7. But the first one, which is 2 power 0, will give us 1. Any number raised to the power 0 or any number power 0 will give you 1. That's how binary is. Now, what do we mean by this? This same number can help us. This is all we have to keep at the back of our mind. 2 power 0, 1, 2 power 1 is 2 in all the formats. So I'll just do this. But then this time around, I'm going to rewrite them and then make it a bit more cleaner, just so you know the concept. Binary is the backbone of every IP address we see, and also every subnet mask we see. Okay, so let's start with 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7. This is 1, 2, 4, 8, 16, 32, 64, and 128. All right, there's one more thing we have to discuss here. Every IP address, for example, what we have on our screen, which is 180.240.1.4. We said this is made up of 4 numbers. 4 numbers. What it means is that every number can be divided into a binary. So we say that every box represents a number of binary digits. So what do I mean? Every number, like what we have here, can be translated into 8 different zeros and ones. So we have, this may not be a direct translation, but we have maybe 1, 2, 3, 4, 5, 6, 7, 8. This is what I mean. So each number can be translated into something like this. All right. Now, all we have to do, the first stage, is for us to rewrite this in a backward format. So we start with 128. So 128. The next one is 64. The next one is 32. The next one is 16, 8, 4, 2, and 1. This is just reversing it. So if you look closely, you could see that it's just these numbers, but this time around, we're writing the first one first, and then in that order. What we're going to do now is going to translate a particular number into binary. So in order for you to do that, let's say we want to translate 180 into binary. This is a very good exercise, and I promise you, you're going to get this. Everything we've done so far is just so you know that each number can be split into each IP address can be split into 4 numbers. So you can see one number here, another number here, another number here, another number here. And for each number, we can split it into 8 different zeros and 1. So the concept of splitting a particular number into 8 different zeros and ones is what people refer to as a byte. So 1 byte. So 1 byte equals 8 bits. What do we mean by bits? A bit is a 0 or a 1. So each number can be translated into 8 various zeros and ones. That will give you a byte. So a byte is just a box. Just let's assume a byte is this box. But if you break the byte into binary, we'll have 8 different zeros and ones, which we refer to as a bit. So 1 byte, which is 1 box, is equivalent. So it's like saying 1 box of chocolate is equivalent to 8 pieces of chocolate. So 1 box, which is the byte, is equivalent to 8 pieces of chocolate. All right. Now, let's pick the first number, 180. We're going to do some analogy here. Let's assume 180 is money you have on you. Just so you know, I'm going to use a pound sign just to signify that it's 180 pounds. You can decide to use any other symbol or any currency, wherever you are. It can be dollars, it can be any currency, depending on where you're coming from, just to get an idea. So this is how much money you have on you. So the 180 is the money you have on you. That's just showing you how to do that logic. And these ones, it means we have 8 shops. So 1, 2, 3, 4, 5, 6, 7, 8. Fair enough. Now, in these shops, all they sell are the same items. So they sell, let's assume they're selling chocolate. But then in that shop, each box contains, this first shop, each box contains 128 pieces. The next shop, each box contains 64 pieces. And the next shop, each box contains 32 pieces. In that order, 16 pieces, 8 pieces, 4 pieces, 2 pieces, 1 piece. Now, why are we doing this? The idea is for you to go into a shop and buy the maximum you can buy, so that you don't waste boxes, or you don't buy more than you have to. So what I mean is, if you go into a shop, let's assume we started with the 128 shop. If you go into that shop, all you have to do is you pick a box, and that means you've picked 128 pieces. But why are we doing this? The idea is so that we will not have a lot of boxes in our car, because we're doing this so that we can have only a few number of boxes in the car. Okay, it may be a bit tricky. Let's see this. You have 180 pounds. Yeah, you go into a shop. The shop has 128, 64, 32, 16, 8, 4, 2, 1 pieces in a box each. So this shop has 128 pieces in the box. This has this in the box. In order for you to get the minimum number of boxes in your car, you have to go into a shop and buy the maximum you can buy from that shop. Okay, let's start from the big shop. The biggest shop is having 128 pieces in the box. One item costs £1. One piece costs £1. So roughly, if you come back home, you should have 180 pieces. So one box is £1. So if you have 180 pounds, you have 180 pieces. So when we're counting them, we're going to count them in the boxes. Now, this box has 128. So we go into the first shop and we buy 128. So if you buy 128, this will give you 2, this will give you 5. That's 0. So you have 52 left. So it means you have 52 pounds left. So this is the shop we went to and we bought that. Don't forget that we want to go into a shop and buy the maximum we can buy, but then we don't want to go into a shop and then buy more than one box from that shop. That's the idea. Don't buy more than one box from that shop. Buy the maximum you can buy from that shop, but start from the biggest shop. Okay, we have 52 pounds left. Can we buy 64? Because 64 will cost us 64 pounds. We don't even need 64, we need 52. So no, we cannot buy it. We go into the next shop and then we see whether we can buy 52 from a shop that sells 32. Yes, we can buy because we have 52 pounds and they are selling 32 pieces. So which means we can buy 32 pounds from there. So 32 We still have 20 left. So any shop we buy stuff from, we put a 1. A shop we have to ignore, we put a 0. Now we go into the next shop. The next shop we have 20 pounds, and the shop is selling 16 pieces for 16 pounds. So we can buy that. So we put a 1 here, we left with 4. We go into a shop that has 8 pieces. We have only 4 pounds left. No, we cannot buy from there. We go into the next shop selling 4 pieces for 4 pounds. Yeah, we have 4 pounds. So we buy that. Now we don't have any money left, so the rest will be zeros. It's a bit tricky on the first one, so we'll take another example, but this is what we mean by converting from decimal to binary. So let's look at this again. In this particular shop, you could see that we bought one from 128, we bought one from 32, we bought one from 16, we bought one from 1. If we add these numbers, 128 to 32 to 16 and to 4, if you sum that up, you get 180. And when we try to translate 180 into binary, we have 1. So all these numbers will come down 0, 1, 1, 0, 1, 0, 0. This is 180 in binary. I know this first example was a bit tricky. We'll take another example, which will be a bit clearer. All you have to assume is the fact that we have 8 shops and they can sell some maximum of item. You cannot buy less than that item, and you cannot buy more than 1 box from that shop. So the first shop sells 128. How did we know that? That's 2 power 7. The second shop sells 64 because it's 2 power 6. 2 power 6. This is 2 power 5. That's 32, 16, 8, 4, 2, 1. Okay. Let's take the second example, 240. We have 240 pounds. And we have to convert that into binary, or 240, we have to convert that into binary. We have 240 pounds. The first shop is selling 128. Can we buy it? Yes, we can. So we buy 128. So we put a 1 here. This is 2, this is 1, and this is 1. The next shop is selling 64. Can we buy it? Yeah, because we have 1, 1, 2, 64. So this will be 12, 8. This is 10, this is 4. So 48. So we bought from the second shop. 48. Can we buy from the third shop? Yeah. Third shop is selling 32. So we buy. So 1. This is 6 and this is 1. So we have 16 left. Can we buy from 16? Yes, we can buy from 16. And that's 0. So 1. We have 0. Can we buy from 8? No, we cannot go to that shop. We don't have any more money left. So 240 in binary has been translated. So 240 has been translated into binary using the same idea. So we'll say that 240 in binary equal 1, 2, 3, 4, 4 ones, 1, 1, 1, 1, and then how many zeros? 1, 2, 3, 4 zeros. So this is 240 in binary. If you have to translate a third one into binary, you have only 1. You cannot buy from this shop because you have only 1. You cannot buy from this shop, you have only 1. You cannot buy from this shop, you have only 1. Same in that order. You can only buy from the last shop. So we have 7 zeros, 1, 2, 3, 4, 5, 6, 7, and a 1. So we have, in order to convert it from decimal to binary, you will see that you can only buy from the last shop. So we have 0, 0, 0, 0, 0, 0, 1. So we have 7 zeros and a 1. That's converting that particular number into binary. The next number we're going to look at will be 4, which is the last number in the IP address. I know this is a bit tricky. It'll be fine. So let's see. We have 4. We cannot buy from this shop because that shop is selling 128. We cannot buy from this shop. 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 But we have 4 pounds and there's a shop selling 4. That will give us 0. So we have 1 here. Are we buying from 2 because we have only 0? No. cannot buy. So 4 in binary will give you 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros, 1, 0, 0. And this is 4 in binary. Typically, this is how the numbers are seen by your computer. So let's just take this example one more time, but this time around, we're going to do everything on one line. This is what the computer will be seeing. We'll be seeing 32 numbers. This is 8 numbers, zeros and ones, another 8 zeros and ones, another 8 zeros and ones, and the final 8 zeros and ones. So we have 32 numbers. So let's watch it. Let's start with the first one. So we'll say 128, 64, 32, 16, 8, 4, 2, 1. We're going to work out 180. So let's see this. 180. Can we buy from the shop? Yes, we can buy because we have 180. So when we take that from that, we have 2 here. This will give us 7, 5, and this is 0, so 52. So let's move on to the second number, 64, and we have 52. So now we have 52. 52, can we buy from 64? No. The item costing us 64, but we have 52 pounds. We cannot buy that, so that's 0. Can we buy 32? Yes, we can buy 32 because we have 52 pounds. So that'll be 20. Can we buy 16? Yes, we can buy 16 because we have 20 pounds. That's 1. We have 4 left. Can we buy 8? No, we have only 4 pounds. Can we buy 4? Yes, because we have 4 pounds. We have 0 left. Can we buy 2? If we have 0, no. Can we buy this? No. So the first number, which is 180, when it's translated into binary, we have what we have down there. The second number, which is 240. So we'll start 128 again. So this is the boundary. This is the first number, 180. It's up to here. Yeah. The second number will be 240. So let's start 128, 64, 32, 16, 8, 4, 2, 1. Let's try that. 240. We did this example, so we have 240. We can buy 128 because we have 240 pounds, so that's 1. So what do we have left? This is 2. This is 3, 1, 1. Can we buy 64? Yes, because we have more than enough. This is 8. This is 10. So we have 48 left. So can we buy 32? Yes, because we have 48 pounds. So 32, we have 16 left. Can we buy 16? Yes, because we have 16 pounds. And that's 0. So we have 1 here. This will be 0, 0, 0, 0. So that's how you write 240 in binary. And how are we doing this? We're just doing some subtraction, repetition of subtraction. That's all we're doing. Next one is 1, easy one. So this is the boundary. This one is 1. So we have 128, 64, 32, 16, 8, 4, 2, 1. It's a bit clumsy, but let's see. 1 is the simplest one. We cannot buy 128. We cannot buy this. 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 That, and we can only buy this. And the last one will be a 4. So 128. So this is the boundary again. Up to here. 128, 64, 32, 16, 8, 4, 2, 1. All right. It's a bit clumsy, but yeah. So we have 4 here. Can we buy 128? No, we cannot buy 128 because we only have £4. Can we buy 64? No, we cannot. We cannot buy 32 in that order. We've done that. Yes, we can buy 4. We cannot buy 2. So if you buy 4, we left with 0. We cannot buy 2. We cannot buy 1 also. So this is what we have in binary. What do I mean? Now, this particular IP address has been translated, which is what we have on the top, 182.40.1 and 4 has been translated into binary. So we have 1, 0, 1, 1, 0, 1, 0, 0. This is 8 numbers, 1, 2, 3, 4, 5, 6, 7, 8. That's 180 for you. And there's a dot representing our dot here. Then we have 1, 2, 3, 4 ones, 1, 2, 3, 4. And how many zeros? 4 zeros, 1, 2, 3, 4. This represents our 240. The next one is 1, 2, 3, 4, 5, 6, 7. So 7, 1, 2, 3, 4, 5, 6, 7 zeros, and a 1. And the last one represents the last bit, which is 1, 2, 3, 4, 5 zeros. So 1, 2, 3, 4, 5 zeros, and a 1 and 2 zeros. 1 and 2 zeros. So basically, this is how your computer will see the IP address 180.240.1.4. This is how the computer sees the IP address. And this is how we convert from decimal to binary. So for converting from decimal to binary, you pick the number, you have your 128, 64, 32, 16, 8, 4, 2, and 1. And all you have to do is go into the shop and see how much you can buy with the money that you have. And the money will be represented by the IP address number you have for that particular place, or we call it an octet. So this is an octet. So this particular octet is having 180. So that 180 can be translated into binary. So you pick the number and then you start doing your subtraction. That's how you convert from binary, so decimal to binary. One advice I'll give you on this is you cannot have this right the first go most of the time. So even though you may have it right, it's just your mind playing some tricks on you. You have to continuously repeat it to understand the logic. And the logic we're using here is that every number you see up here represents the money you have in. So if you pick 180, the 180 represents the money you have in. That's the logic you should take from this particular page. 180 represent the money you have in, or all the numbers are representing money. And the 128, 64, 32, 16, 8, 4, 2, 1 represent shops where you can spend your money, but you only spend the maximum that the shop is offering. So you cannot buy more than 128 from this shop. That's what it means. You cannot buy more than 64 from this shop. You cannot buy more than 32 from this shop. You cannot buy more than 60. And we are doing that in a way that, okay, if that's the case, then we have to buy from the bigger shop, because if we start buying from the bigger shop, then we'll have fewer number of boxes in our car again, as we said earlier on. So just so we wrap up this particular page, I'll do 180 again, but this time around, taking at the back of your mind that money is representing the numbers you have here, and then also these are the shops and how much they're selling their items for. So if I pick 180, which is the money I have, and I go into that shop again, this is just continuous repetition. The reason why I do this is in networking, you have to continuously practice it. And I would advise that you continuously practice this. Apart from the fact that you have the video, you have to continuously practice this. If you have any issue, you can send me a comment and I'll reply to it. You can also continuously watch the video, repeat the video. And the more you do that, I bet you'll be able to understand it. So this is the money we have in it. And then in this shop, we have 128 items. So we can buy from that shop because we have more money. So I buy from this shop. So 128, and that's 10. That'll give you 2. So, yeah, you have to know how to do basic maths. You can use a calculator. Nobody will bother about that. Now you have £52 left. that shop is selling it for 64, so you cannot buy from that shop. So you have less money. And then the next shop is selling 32, you have 52. So 32 you can buy from there. So if you subtract 32 from 52, you have 20 left. So can we buy 16? Yes, we can buy 16 because we have 20 pounds. So 16. That's 4. Can we buy 8? No, because we have only 4 pounds. Can we buy 4? Yeah, we can buy 4 because we have 4 pounds. And that's 0. Can we buy 2? No, because we don't have any money. Can we buy 1? No, because we don't have any money. And this is how you convert from from decimal to binary, or continuously slip binary to decimal, but you have to be careful. The content here is saying from decimal to binary. So from normal numbers that we already know to zeros and ones, that's binary. Now we're doing this again because this is how computers see stuff. Repetition in networking is a very good thing, and don't shy away from that. We'll continuously do that in every aspect of what we're doing. So in this particular page, the takeaway is what you would have to remember, or the driving one would be how to convert from decimal to binary. And we said you can do that by, first of all, splitting the numbers into 8 different numbers, starting from 1, 2, 8, 64, 32, 16, 8, 4, 2, 1. We also mentioned how we got there. We said this is 2 power 7, 2 power 8, 2 power 6, 2 power 5, 2 power 4, 2 power 3, 2 power 2, 2 power 1, and 2 power 0. Now, I would advise that you continuously watch this video. I bet you if you watch it more than once, minimum twice, you should be able to get hold of this, because the first one will give you a general idea. The second one will be able to answer the questions that you had after watching the first one. So I advise you continuously watch it until you have some questions for me. If you don't get a concept, just send me a message and I'll kind of reply to it and make some clarification to you. We were supposed to do more than that in this particular session, but because the session is a bit longer, I don't want to drag it. So I'll cut this particular video and then we'll come back on a part 2 of this video and see how we can do the reverse, converting zeros and ones to decimal, which is a very easy one. So I'll advise you go over that particular one we did, and then we'll come back. If you have any questions, just send me a comment and I'll reply to it as soon as possible. I wouldn't leave it for a day, maybe a few minutes, and I'll have to reply to it. Thank you very much.